Okay, so I'm going to create a point on a plane. And I'm going to create another point on a plane on this YZ plane just to keep it simple. Create another line, create a point on a plane. And another point on a plane. Remember I had you do all these in 185, creating lines. Okay, it's wireframe lines. I can connect these two ends using the line command, right? I got to make sure to grab the endpoints though. Oh, you're killing me. Point to point, I want to grab that point. And this point, select OK. Are those lines adjacent? Anyone?
Yes. Yes, they are.
Yes, they are adjacent. Are they tangent?
No. Oh.
Would you agree that from this line to this line, that's not a smooth transition?
That's correct.
That
Yes,
would be
I
an
agree.
angle. Would you guys would agree this is an angle, yes?
Yes. Yes.
And this is an angle as well.
Yep. Right.
Okay, so the number one problem in production with NC parts is they don't have adjacent elements. So for example, if you create a line on this plane from here I'm getting interference from someone's
Hey,
mic.
Raphael, that's what a lot of interference coming from your mic.
I'll select OK. This line is not adjacent to this line or this line. Agreed?
Yeah.
In other words, well, who can explain to me why is it not adjacent?
Because they're not next to or touching each other.
They do not share the same endpoints, right? These endpoints do not touch. These endpoints do not touch. I was in NC programming group and I get stuff like this all the time. And I'm like, I can't machine that. They're not even touching. If I go and create the other line, this line here, I'm altering the engineering part. This is not what they gave me. If I go and machine this out, this is not what I was given though. Okay, I may have fixed it so it's right, but in all reality, I shouldn't have done that. Engineering has to decide that that's the line they want. But we get that all the time. Elements that are not adjacent. Okay, so we're all in agreement that this line is no good. I also showed you another way to connect this line to this line and have a smooth transition. Does anybody recall an exercise where I showed you how to do that?
Connect curve or conics.
No. Anybody?
Are you talking the corners?
Corner command. Under corner, I could select this line and I could select this line. Oh, that's nice.
Or can you?
Yeah, or can I? I don't know why. It's not letting me do that. Great.
Is it not like that connector line?
It shouldn't even matter. They don't recognize each other. Corner. Second element should be this one.
Try doing it in order. Pick that other one first.
That's a great idea. It probably won't work, but that is something I always recommend, is to switch your orders up if it doesn't work. I think the problem is that they're not intersecting each other. Okay, so anyways, if I did get a corner on there, you would have adjacent and tangent. But I would have moved and changed the endpoints of the line. Do you remember that earlier when I did a conic in the sketch? How I did that corner and it actually extended the lines out?
Yeah.
But our goal is to make a nice smooth transition. So someone brought up connect curve. So if you didn't do 193, you might not have seen me do this or finish 193. But connect curve is an interesting way to take this point and reverse the direction, grab this point, reverse that direction, and I got a smooth transition from one element to the next. So I'll ask you, is this curve adjacent to the two lines?
Yes.
Is it tangent though?
No. Probably not.
What does this say here?
Oh, it says it is.
So I did make it tangent. Okay?
Yeah.
So it's a tangent curve that connected the two that maintain tangency. In fact, something you could do would be to select curvature. And did you see it bulge out a little more?
Mm-hmm.
There's point. Oops. I'm on the wrong one here. So here's point number one. Is that look tangent to you?
No.
If I switch this to tangent, does it look tangent now?
Yeah.
If I switch this to curvature, does it look tangent?
It doesn't look like it over here.
It is tangent, and it's extrapolated to hold tangency even longer than it was before. In fact, if I increase my tension, I'm smoothing that out. Same thing on this one up here. This is for number two, point number two. If I change that to point, see how it goes right sharp to the point? If I change that to tangent, I know I've got a tangent, see, from this curve to that line at that point. If I want to extend the tangency, I can switch it to curvature. Did you see how it bulged it out a little more? In fact, I could increase my tension here as well. Increase this tension. So I've got my tension increased to 2 on both of them. Now, if I had left it at tangent, you'll still see the reflection lines. If you recall me talking about that the other day, you'll see reflection lines on that part, okay? But now that I've increased the tension, I shouldn't see the reflection lines. That should have smoothed that out. And what I can do you guys know a way I can make this line and this curve and this line all one entity?
Yeah, isn't that a join thing? Or
Join.
something?
Yes, I just got to figure out where the heck that join is hiding.
Yeah, that's just part of it.
Isn't that refine?
I'm going to transform the two lines and a curve into one joint element. So I'm going to select join under transform. I'm going to select join, and I'm going to join these elements. I got a line, a connect, and a line. It says it's got 3 elements I'm joining. Can you guys see that okay?
Yep.
I'll select OK. Now I did something wrong. I should have a yellow F on the join. What did I do wrong?
It's not federated.
Not federate.
We've got to turn on the federation. Under advanced, where it says no federate, I join it using all. I'll hit preview, and now can you see a little yellow F on there? It's so tiny it's hard to see. I'll select OK. That just, all it does is when I put my line cursor on this, the whole thing should be highlighting versus highlighting just the 3 sections. I honestly don't feel like it changes anything, but some companies are headstrong on making it say federate, not really knowing why. But let's say I'm making a wing, right? Have I showed you a way to create a surface from this? What kind of surface could I create from this? Which type? An extrude.
Extrude, yeah.
You guys remember doing those extrudes? It's like this. This is probably my #1 go-to in production. You see, the hard part wasn't the surface. Much like solids, the pad is the easy part. It's the sketch that takes me a long time to make. And much like surfaces, it's the wireframe that takes me more time to create. I'll just go ahead and increase this a little bit. Select OK. And I wasn't paying attention to the error message. So if you were making a wing, this would be all one nice surface now. Okay. So I'm going to hide.
Isn't it showing that the lines on it, the shadows?
It's still all one surface. I'm going to pull these out.
Isn't that showing the reflection lines still, or?
It's just showing me that it's a joint at that point. It's not really, it's not what I was saying the other day, that that line is the reflection line. I'm just telling you the last one, that's where the reflection line would be. Remember, if you look at the top of your computer where it's cornered off, I bet you everyone has a corner on the top. If you look on the top, you'll see the reflection line because they just basically used the corner command. They didn't use conics. Or
Mine has conics.
yours has conics?
Yeah.
I'd be really surprised to see that.
It's definitely got a paper from front to back.
Okay. That might not. Conic doesn't mean it's tapered. That could be a tapered fillet. I don't know though.
Yeah,
I can't see your monitor, so I can't tell you for sure. But
yeah,
almost everything built is just got corners on there because it's the fastest way to do it. It's a lot, like this monitor doesn't have to be aerodynamic. They might have did it to make it look more aesthetically pleasing. Okay, so I'm going to hide this again, and I'm going to create a new geometrical set. In this geometrical set, I'm going to create wireframe, and I'm looking for conic. The support. Does anybody have any idea for this? What would be a good support?
your plane.
Yeah. This plane right here. That plane on the YZ. Where am I going to start? I'll start here. Where am I going to end? I'll
You're at
end
the point.
up here. Now you see, if you just watch the box, wherever it highlights, just try and answer the question where it's highlighting. It's saying tangent start. What do you think it's asking me for?
Probably the bottom line.
Yeah, the bottom line is what I want to hold tangent to start point 1. Now, it seems inconsistent. It seems like normally it says, where's your start point, what's tangent? And then what's the next start point, what's tangent? But with this one, a different programmer's in here, and they made it pick the start and the end and then come back and hit your tangent lines. So I picked this tangent line and this tangent line. Okay? And then the parameter is 0.5. It's telling me it's a parameter of 0.5. What type of conic is that creating?
Parabola.
Exactly. I'll say okay. All right, and that's how I created a parabola. I'm going to hit undo. Repeat the steps. Under connect, what was different? Okay, under conic, it asked for first point, second point, correct? In this one, the first thing it asks for is the point, and then it grabs the curve that is a line of curve.
Yeah.
Yes, it has infinite radius. Tangent, it's already doing that. All I had to do is grab that one point, and it knew to grab that line. And this is where some of the inconsistencies are, right? That's what makes CATIA confusing to me, is how come you don't do the same format basically when you're doing the same things? It's because you got different programmers setting it up differently. Or you got one
Is that
guy.
really what it comes down to? Is just a different guy did it a little different?
For the most part.
Huh.
Because there's so many features on here, right? So not one guy is doing them all. Okay, second curve. It's asking for the point. So I can grab this point here, highlight that, and I grab this point. Again, it defaults to all of this. The only thing here is it has arrow directions that I have to invert, where Conic's, it knows where I'm going because of the parameter. But you notice that it's basically the same, but different selections, or different order of selections, but the same selections, yes? So again, under Conic, select the support first, just follow the box, select the start point, the end point, the start line that's tangent, the second tangent line, key in the parameter 0.5, select OK. I will compare that to my connect curve, and look how I got a little bit of difference. This connect curve almost looks like what? What would that be called?
An ellipse.
It'd be called an ellipse, yes.
Or an ellipse, yeah, sorry.
Okay, so this is more of an ellipse, but guess what? It's not really. If I grab this and try and move that parameter down, I'll try 0.35. See, it's going to give me a different result. So my question to you is, which one's better?
Look at it.
Aerodynamics, the Conic's better.
The Conic. Seems like it would be.
Here's what I'm going to tell you.
It's more difficult, right?
What's that, Dane? Michael Dane?
Just because the Conic's more difficult, it makes it the right one?
No. No.
It seems like it's just a smoother curve.
So I'm going to tell you this right now. The reason why I'm showing you both is because I don't know which one's best. Which one's best depends on the application. I'm going to show you multiple ways to do something, but when you get out in production, you don't know which one's best. Sometimes I have to create both, actually build the surfaces, and then test it and see which one actually is the better surface. Does that make sense? There's no right answer here. It's your design and how you interpret what you want as the end result. for aesthetics and aerodynamics, practicality. Okay, there might be issues that cause, like maybe this parameter, there's interference with something on the inside of this. So I had to bulge it out more, and the only way I could bulge it out more was to switch it up from a conic to a connect curve. If one was better than the other, I wouldn't bother showing you the other one. I'm showing you multiple ways to do things so that you in production can figure out which one to use when you need to. But before you can figure out which one you need to know, or which one's going to work best, you got to figure out how to manipulate these. So that's what this class is going to be about, learning how to just create the surfaces, to create the wireframe, and then when you go to design, you'll have different applications you can try to get to work. If one doesn't work, you can try another application. Okay, I'll cancel that. Any questions for me on that so far? Based on that, your demo, whoops. Here is a Word doc. I want you to open up the Word doc. So you hit this arrow here and download that. I'm going to give you specific parameters to create your lines. You're going to create the 3 different types of conics. Your tree should match mine. Notice that I'm labeling the types of conics I have. I'm giving you, well, I didn't give you the parameter for the parabola because you already know that, right?
Yep.
And then you're going to create 3 surfaces like I did using all the different types of conics in this example. Any questions on that?
No.
Okay, let's go try and knock this out real quick. I'm going to stop the recording.